All right, let's talk about empirical formula. Now, why do we care about empirical formulas? This is always the question we want to ask, is why do we care? So empirical formula is something that we get when we have an unknown compound, and let's say we isolate it from something, someplace, we grind up a leaf and we find some compound of interest and we want to know what it is made of, right? So we purify the compound, we get it away from all the other compounds in there, we get it pure, and then we say, what is it made of? And so we do some analysis on it in a lab. We either send it away or we do the analysis ourselves, and we come up with some statistics or some kind of data on it, and the data comes back and it looks like this. It says we have 52.1% carbon, 13.1% hydrogen, and 34.7% oxygen. Well, that's great. That doesn't tell us what the formula is. So we need to figure out from this data what the formula of the compound is. There's further we have to go after that, but this is the first step in figuring out what the structure of the compound is. Now, this is percent by mass, so that's an important thing to know, percent by mass, okay? So what does percent mean? It means per 100. Cent means 100, right? So per 100. So that means out of 100 grams, 52 of those grams will be carbon grams, and 13.1 of those grams would be hydrogen grams. So if we had 100 grams. In order to do our analysis to figure out what the formula is, we're going to just say, let's say we had 100 grams, because that makes these numbers easier to work with. So let's say we have 52.1 grams of carbon, and I have 13.1 grams of hydrogen, and I have 34.7 grams of oxygen. Now I can't put that in a formula because chemical formulas are not by mass. You know that, right? It's by number of atoms that we have, like C2H6O or whatever we had, or C3H8O2 or C4. You know what I'm saying? Those numbers in there are by numbers of atoms. So we need to figure out numbers of atoms, not by mass. And so we're going to change these into a number of atoms. And the way we do that, of course, is by changing it to moles. So to change carbon, we would have to multiply it by its molar mass, of course, upside down, because we want the grams to cancel, right? And so we're going to get, when we do this, we're going to change our grams of carbon, we're going to get 4.34 moles of carbon. All right, let's do the same thing for hydrogen, all right? So we're going to say, what is the molar mass of hydrogen? 1.008 grams of hydrogen for 1 mole of hydrogen. Comes out almost the same, right? So we're going to have 13.0 moles of hydrogen. And then we're going to do the same thing for the oxygen. I'm going to take 16.00 grams of oxygen is in 1 mole of oxygen. And I'm going to end up with 2.17 moles of oxygen. So now we have a number ratio, which is great. That's so much better than what we had before, right? However, we cannot make a formula and say, I have C 4.34, H 13.0, O 2.17. It doesn't make any sense. There is no such thing as a 0.34 carbon, right? So I can't do this. These have to be whole numbers down here. So we have to have some way of converting these into whole numbers. So what I'm going to do is take each one of these and say, this is just a ratio, right? It's just a ratio of how many we have compared to any others. So I'm going to take each one of these numbers, 3.34, 4.34, 13.0, and 2.17, and then divide every one of them by whichever one is the smallest. So we look at these and we say, which one's the smallest? Well, I think 2.17 is clearly the smallest of those 3 numbers. That's going to equal 1. What does that equal? Oh, I think that equals 6. How about this? What does that equal? Well, that equals 2. So this is the carbon, right? This is carbon here. This is hydrogen here. This is oxygen here. So we're saying that in a ratio, I have twice as many carbon atoms as I do oxygen atoms. In a ratio, I have 6 times as many hydrogens as I do oxygen atoms, and then oxygen to oxygen is 1, right? So I can now write this formula as C2H6O. Now, I still have not gotten to the molecular formula. I've only gotten to the empirical formula. What's the difference? I know the ratio. I can't say that in this molecule there's only 2 carbons, only 6 hydrogens, and only 1 oxygen. Maybe there's 4 carbons and 12 hydrogens and 2 oxygens. Maybe there's 3 times as many of this. But this is the ratio, at least, in which they occur. We have to go one step further and consider the molar mass in order to get to the molecular formula. Next video.